So over or under estimates, got to think about what does a left sum look like, what does a right sum look like. So if I were to draw a function, and I'm going to just tell you right now, I'm going to spoil it right now, it's going to depend on if it's increasing or decreasing. So let me just go ahead and draw in just a random increasing function, just always increasing, right? And a random decreasing function, or I'm going to draw it twice actually. And a random decreasing function, I'll draw it twice. Okay, so a left sum means so we'll make this our left sum. And this one our right sum. Oh wait, we couldn't do that. This is our increasing and that's our decreasing. Got that a little backwards there. Okay. Okay, let's just look at our increasing. So a left sum means that the left ends are touching on the rectangles. So if you were to draw rectangles in which the left ends are touching, you'll see that it's underneath the graph. So this would be an under. So on our increasing graph, the left sum is an under approximation. What about a right sum though? If you were to draw the rectangle so that the right ends are touching, what you'll notice there is that's going to be an over approximation. So in the function that is increasing, our right sum is an over approximation. And you could guess this is going to flip around for over here. I don't know why I drew them so far away from each other. Let's bring them over here and get nice and close to each other there. So if we're decreasing, let's start with our left sum. Let's see what happens with our left sum. So we want our rectangles to touch on the left. So notice how I'm starting from the left and going right with those. You'll see that our rectangles are over it. So this is an over approximation. And then over here for our decreasing, and we'll do a right sum. So I want the rectangles to touch on the right. That's going to be an under because it's underneath it. So increasing or decreasing is what's going to help us realize is our left or right Riemann sum an over or under approximation. So what I recommend that you do is whenever you get to the algebra or a table or things like that, picture it and draw it. It really helps to come back to the drawing. You can always just quickly draw, try to determine, hey, is our function increasing or decreasing? And if you forget, draw an increasing function and then draw a left sum or a right sum and see if it's an under or over. So right here, order the areas from least to greatest. So if I drew a left sum, you'll see that it's going to be underneath because it's an increasing function. So left sum is going to be the last one on our list. It's the lowest. If I draw a right sum, you'll see it's over. So the right sum is going to be first on the list. And then the actual area is always number 2 on these. But if we go over to decreasing, notice the left sum now. If we draw our rectangle so the left are touching, the left sum is actually the highest point. Then the actual area, and then the right sum will be underneath. Now, that's not always going to just be a nice, neat graph. What you might end up having here is a table. So let's look at this table. 41, 35, 29, 24, 19, 11. What are these doing? They are decreasing. Our graph here is decreasing. So if we were to figure out, okay, a left sum would be over. So that would be the greatest, then the actual area, and then the right sum would be underneath. This one, though, on the other hand, if you look at these values, are increasing. So if you draw a left sum, that would be underneath. So it would be last, then the actual area, and then right would be first. And that's the idea. You're looking to see if these are increasing or decreasing.